Hi everyone, this is the lesson recap for Thursday, February 17th, for those who missed it and for those who want to review. Just a quick reminder that the due dates for inquiring and analyzing and developing ideas are at March 12th. That's about 3 weeks off, so we have a little bit of work to do in there. Now, since the school is closed for another couple of weeks, out to April 20th, we have officially switched from robotics to C programming. And I'll talk a little bit more about that in here. Now, we have prepared a new handout. You can, if you click on lessons page up here and click on class handout, you can now see it's about C programming. By the way, if you want to pursue C in more detail, this is a link to a classic book on the C language. This was written by, you can see it here, Brian Kernighe and Dennis Ritchie. These are the authors of the language, and they also are the creators of the Unix operating system. C was created to write the Unix operating system, or at least to make the Unix operating system more portable, make it portable, so they could run it on other computers. Note also, C is one of the oldest and most popular programming languages, and you can see other popular languages here at this source link. Now, there is something to say also about the design folder document. Well, before we get to that, the handout for inquiring and analyzing stage has been updated for the C programming course. The other three stages, we have not changed these, so these still refer to robotics, and we will change those quickly, especially this one, developing ideas. Now, back to the template or the design folder document. Now, for those of you who are not in the class, then let's go look at someone's document. I'm just going to pick 921. I'm just going to pick the first item. Now, I think, let's do this instead. But if you were not there, I think everyone has already done this, so you won't see what I'm talking about. So let's go back to here is the year 9 material, and let's go back one more level.
It's 16 hours.
The template from which you created your design folder document. Here it is. It includes an appendix down at the bottom. So in your design folder document, if you haven't already done this, can you please remove this appendix from your document? Just come down here and remove this whole section. This is where we were putting the robot C code. We're not going to do that. So that's the only change you have to make to your design folder. Well, in addition, you should change this name. I'm not going to change it here because it's a template. So this, instead of saying Introduction to Robotics, it should say Introduction to C Programming. All right, that's enough for that. Now, we have been in the inquiring and analyzing stage since the beginning of the course. And we've been inquiring about the C language, which we thought would then fold into the robot C language we use for robots, but that's off. So now we've been inquiring about the C language because the project is now to create an application in C. So let's take a look at the Need for a Solution section. And note that it has the letter C in parentheses on all the pages now. So if you don't see that, you're looking at the wrong handout. Now, you should not have access to the old handout. If you made a copy of the old handout and downloaded it to your Google Drive, just note that we're not using that one, and I recommend you just remove it unless you want to, explore it for your own interest. So, need for a solution. So, overview. In the need for a solution, you will talk about the solution or the application you think you want to make, and I'll give you some ideas for that in a minute. So it says need for a solution. Well, that implies there's a problem. So the problem is you will state what it is that's needed. So I need an application that can manage student grades, for example. So that is the problem, and that is the need. That is the problem. And if you have a problem, you have a need for a solution. Guys, these headings come from the IBO. I wish we could just simply call this, problem statement or something like that, but we don't. So in here, you'll discuss at a very high level your game or your application idea. Then in the research plan section, you will explore certain things that you will need to gather information on. For example, suppose up here in your application, you decide, I want to save some data to a file. Well, you may not know how to do that yet. So during your research, you will consider, okay, where can I get information about writing to a file and reading from a file in C? Now, we're going to talk about this stuff later, but for now, when you come up with an idea, do not be constrained or limited to your present skills in C. Just come up with an idea, and if you think you like to do something, just say it, whether or not you can presently do it. This is very similar to what you did in Scratch. At the very beginning, you had to come up with an idea for a Scratch game, and the game had to include levels and obstacles and lives and scoring, most of which you would not have known how to do at that point. And that's fine. We will discuss how to do these things as we go. So here is where you're going to do a little more exploring to see what it would take to implement some of those features. Existing products is where you're going to try and find projects that have already been implemented that are similar to your idea to get some sort of inspiration or guidance about, what features should you include. This doesn't mean go grab a project and get the source code and rename it as yours. That's not what we're talking about. And then the design brief is a summary of your findings. So in the design brief, you will answer the questions you created up here in the plan, summarize what you found by looking at other products, and you'll give a little more detail about the application features you're thinking of building. And then the bibliography should include some sources, because this is research. This is not just your opinion, it's about what other people and the experts think. And of course, there's the rubric, and we'll come back to that in a minute. So the immediate task is this need for a solution. So let's zoom in on here. So the problem to be addressed in this unit is to design and write an application in the C language. And here are some examples. So you could build a calculator, which, for example, displays a menu on the screen. For example, I keep saying for example, the menu could show things such as all the arithmetic operators, maybe all the relational operators such as less than, greater than. Maybe you could include some trig operators or geometry operators. So I might want to be able to find the arctangent of some angle. And then, so you could prompt the user, which operation do you want to perform? And then they choose the operation. And then you prompt them for the operands. And then you perform the operation and report the result. That's an idea, and you could consult with your math teacher. There are also many functions in the C library that you can use to do much of this work. Now, a follow-on to that could be some sort of math engine where you go a bit further and perhaps you solve some sort of quadratic equation for something else. I mean, the application wouldn't simply solve the quadratic, it would solve it so that you could do something such as, I don't know, display a chart or you guys probably know more about the quadratics than I do. My math is a bit rusty. But why does one solve a quadratic equation in the first place? Well, it's that other thing, that bigger objective that your application would be concerned with, and solving that quadratic would be a way to get to this bigger problem. You could have some kind of student grading system. So the user could input grades for a student, maybe display all the students. You could edit an existing student. You could then show perhaps, what are all the students, what was the average grade for English among all the students. Now, just to give you an idea of what, let me just zoom back out, what a data in a file would look like. Now, the kind of file we're talking about is a simple text file, nothing fancy like a relational database or random access file. So suppose you had a student called, let's just use me, and the student's name is this, and the student is in year 9, and the student took DDES, and the student got a 5, no spaces, and the student took math and got a 7, and the student, sorry, no spaces, the student took English, and you might want to spell out these subject names, and got a 6, and so on, like this. And you could have several students, so I'm just going to copy paste this a couple of times. And the data would be different for each student, of course, but note that each record in the file contains fields, and each field is separated by a comma. Now, this is referred to as a comma-separated variable file, or CSV file. You've probably seen this, where the file name extension is .csv. And the data would look like this inside the file, and then you could read a record from this file. So a record consists of all this, and you'd read this in, and then you'd have to sort of break this apart using the commas as the delimiter between the fields. So for example, I could read all the records, and then I could extract all the scores for math, for example, and then I could display what's the average score for math. That's just something you could consider. And we can talk more about this, but that's just an idea. Another application idea could be some sort of geography application where the user enters a capital and then you display the country, or the user enters the country and you display the capital, or population, or area size, or a really cool thing to do would be, what's the distance between two cities? Now, for that, you would have to tap into something such as Google Earth. And I'm looking at how you might do that, how you could access a web service such as Google Earth from a C program. And then you could get the coordinates, the latitude and longitude for the two cities, and then somehow, there must be a way to do it, calculate the distance, the line of sight distance between city A and city B using the coordinates. That would be cool. And yeah, anything you can think of. Now I'll give you 2 student examples which have come up already. Now, once you have some idea, then you will write a detailed description of your idea, and then get some teacher feedback on this to check if your proposed idea is too simple or too ambitious. And then you're going to just, once you get the feedback, then you'll be able to discuss in a little more detail what the program needs to accomplish. Now, you should record the teacher feedback. You can send me an email uh, telling me that you've come up with an idea. I will look in your design folder document, I'll look it over, and then I'll respond to your email. And then you can record my feedback into your design folder document. I'm not going to enter the feedback into your document. So you record that feedback, and then there'll be a short discussion on soft skills you will need, such as growth mindset, failure, persistence, self-reliance. Remember what Bill Gates said, persistence pays, and it does. Look what it did for him. Failure is not what it used to be. If you are thinking with a growth mindset, failure is simply the elimination of some option. You tried something, it doesn't work, well, you know not to try it that way next time. So try not to get discouraged. Software can be challenging, but with a little persistence, a little self-reliance, and asking questions, we can all get through. So it's good to be self-reliant. Try and break through on your own, but don't spin your wheels. Don't be spending 5-6 days trying to crack a problem. So get help when you feel like you've hit a wall. Now, I'll just give you a couple of examples of what has come up so far for game ideas or application ideas. So this is Ingrid in 921, and her idea is to create a program that can decipher the shift cipher. And we can go look at her. I don't think she'll mind me sharing this, but here is a description of her problem. And she's got some data down here which she's going to use, and I gave her some feedback already, and then she's going to do the discussion later. So it says, I'm planning to create a program that can decipher the shift cipher. The shift cipher takes some text and replaces each letter of the alphabet in the text with another letter. To do this, it needs a shift value S, which is a number between 0 and 25. All right. This is basically an encryption technique. Now, her program is going to receive text that has been encrypted using this cipher mechanism, and she's going to try and, based on this data down here, which she got from this source, she's going to try and decrypt. Well, first she's going to try and figure out what is the shift value that was used to encrypt the message, and then use that shift value to decrypt the message. This is really a great idea. And so let's take a look at another one. Now, Ryan in the other class has an idea for creating a graph calculator, a graphing calculator. And so he has this proposal. He's already received some teacher feedback, and he's mentioned some soft skills. So his idea is to create a graphing calculator. The problem I am targeting is sometimes when students are studying algebra in their math class, it's hard to visualize equations, but it's much easier to look at a graph. Graphing calculators on the market, such as the TI, Texas Instrument 84, may be hard to use, and who wants to carry a calculator when you have a computer? In my application, there will be a GUI. Now, he's looking at tools for displaying something graphical. GUI means Graphical User Interface. So this is part of his research, is to explore this, and he's thrown some things out at me, and I've given him some ideas on this. And I'll have more to say about this over the weekend. I'm also looking at some tools that can help create a more graphical presentation of your application in addition to the simple printfs that we've been doing. I've found a framework that is designed to create text-based user interfaces, and it looks very interesting. I can just show you real quickly over here. It's this thing. It's called, let me go to the previous. Yeah, this is thing called N cursors. And it explains, there's quite a bit of documentation here. I'm not asking you to go through all this, but I'm going to go through some of this and see if I can't uh, distill this a little bit and see if we can't use it in the course. I also found, I'm working on a couple of things for moving the cursor around on the screen. This displays a grid of characters around the screen. And you can, when I get this working a little better, I'll share this with you. This looks promising as well. Now, back to the lessons page. So, this is what you're working on now. I know this might be a little bit of a struggle coming up with an idea, but you can do some Google searches on, project ideas in C for high school students and that kind of thing. And we'll try and get some more ideas from Miss Momeni and Miss Nahar and Mr. Lagos from their year 11 Python and Java classes. For homework, you should try and complete this need for a solution for next time. That would be Monday. And continue working on the exercises, including fixing those that are orange. That's it for now. If you have any questions regarding this, if you weren't able to attend the class online, please send me a message. I'm happy to have a one-on-one with you if you think that would be beneficial. Cheerio. Have a nice weekend.